Let's now understand electrolysis of aqueous sodium chloride. Alright, sodium chloride gets dissociated into Na plus and Cl minus aqueous. Now let's check out what havoc does this aqueous or water play in this reaction. Let us see how does it compete in reduction section and oxidation section for half cell reactions. Alright, so let's move in. Now reduction, half reaction at cathode, half cell reaction at cathode. So what happens? We know for sodium it is all okay. Reduction itself means gain of electrons. So Na plus gains electron and forms Na. E0 for this is minus 2.71 volts. Directly taken from ECS, electrochemical series. Now we are talking in terms of reduction, so there's no issue of changing sign or anything. Alright, so we can directly take this value as its reduction potential. Now at the same time, what happens at cathode? Electrolysis of water also occurs. Now what happens is two water molecule receives 2 electrons, giving you hydrogen gas and OH minus. So it gives 2 OH minus, 2 H2 involved, plus 2 electrons, giving hydrogen gas. And so if E0 for this reaction is minus 0.83 volts. Now, just to make you understand, I have just drawn ECS in short over here. So we know at top we have cathode and the value is approximately plus 2.9 maximum value that we have in our table. Alright. Then again, when we go down below there, whatever table we have received is minus 3 approximately anode. So basically what you have got to keep in mind is higher value of positive is at cathode, higher value negative is at anode. Alright, so positive at cathode and negative at reduction at cathode, oxidation at anode. Alright, so the value I have jotted down in pencil, 0.83, that belongs for water, and minus 2.71 belongs to sodium. Reduction of sodium, reduction of water. Now we find we are talking in terms of cathode. So whichever is closer to cathode would act as better cathode. So here water acts as a better cathode, owing to which, in spite of sodium being there, it is hydrogen gas liberated at cathode, not sodium. Why? Because water has greater tendency to get reduced as we find it to be closer to cathode. Fine, so that's the story over here. So poor sodium Na plus stays there in solution itself. Alright, now let's check out what happens in oxidation half cell reaction at anode. Let's now get into understanding half cell reaction at anode or oxidation. Obviously at anode oxidation occurs. So two reactions, again competition. We have got to check out whether this or this is feasible. Alright, now 2Cl minus oxidation, so it has to lose electron. It loses electron, forms 2 atoms of Cl. Those atoms of Cl combine together to form molecular chlorine gas and is supposed to be liberated at anode, and it also provides 2 electrons. Now E, reduction potential for this reaction is plus 1.36. Mind you, plus 1.36 would be coming closer to cathode, right? All right. Now in case of water, what happens in case of water? Water also gives out oxygen, 4H plus and 4 electrons. So what happens? So water gives out oxygen, and what is the EMF? What is the E0? E0 is plus 0.4. So plus, I just jotted down over here the oxidation. Oxidation, since it is anode, we have got to think in terms of oxidation. So negative. Alright, but this itself would help our purpose. The reduction potential itself would help our purpose. Now 1.36, I've jotted it down here, that is for Cl. That's for Cl, and plus 0.4 is for water. Who's closer to anode? Which of the two is closer to anode? Obviously, water is closer to anode. So, water has greater tendency to get oxidized, but we don't find water getting oxidized. We find chlorine being liberated at anode. Fine, both this and this has reached the anode. These have to be converted to gases. So more voltage is required to convert these into gases, right? Atomic. So this has to be converted into gases. So voltage required for converting oxygen to gas is much more than that required for converting chlorine to gas. Alright, so that's the reason why we find chlorine gas and not oxygen gas liberated at anode. We find chlorine gas and not oxygen being liberated at anode. Alright, just read what I have scribbled over here. This is because of overvoltage required for oxygen could be owing to voltage required for formation of gas O2 is much greater than that for Cl2 gas. Alright, so the competition, both the places we found competition. Here we found that water had greater tendency, so hydrogen was liberated, and here Na remained behind, and here also we found in this case oxygen is not liberated but Cl is liberated. So what we have is we have got hydroxide here, sodium also here, so it forms sodium hydroxide. Alright, sodium hydroxide remains in the electrolyte, whereas it is these two gases which are liberated, Cl2 gas and hydrogen gas, liberated at anode and cathode respectively. Alright, hope you understood. Alright, all the best.